talk about cofunctions, and they have to deal with this idea of complementary angles. Close. 90. 90.
Supplementary is 180.
Good. Good. Supplementary. Right. Those are 180. Okay. So what we're going to think about when we have something that are cofunctions, that means they are complementary, that their angles together would have to add up to be 90 degrees. Now, cofunctions, I think I've seen one question ever on the Regents exam about cofunctions. It's not something that comes up a lot. And for one, I think this is like the first time these trig functions kind of make sense when you think about what a cofunction is. So sine and cosine, so sine and cosine, all right, those are cofunctions. Don't they sound the same, like sine and cosine?
Right, there's a co.
Right, there's just a co, which means they're cofunctions. Exactly right. Right? Same thing with tan and cotan.
Oh, wow.
Cofunctions, all right? Same deal, secant and cosecant are cofunctions together. Now, this is kind of crazy because you guys have learned so many different relationships between all these trig functions. We had the reciprocal ones, now we have cofunctions, which is a pain in the butt, but at least they sound the same, which is nice. Like exactly what Aaron said. They sound the same. One has a co in front of it. Right? The big thing, we don't want to let this confuse you guys what they're talking about here. Basically, all this means is that the two angle measurements have to add to 90 degrees total.
Wait, so if you were to add,
You want to see what in action? And then you can ask? Okay.
Wait, so would it be the cosine of the cos theta minus 90 would have to equal the sine theta?
Yes, exactly, exactly. These are close, so you can always check to make sure you're right. I think once we do one, we'll be, what you're thinking, Miranda. Okay, so you guys would see this on a Regents. This is kind of how they would ask you. Find a value of theta for which this is true. Well, the thing that we know about sine and cosine, they are cofunctions. So what that means is that the two angles have to add up to be what? 90. Good. So if I take, do I know what this angle is?
No.
No. So we can let it be, what would you guys let it be if you don't know?
Theta.
Theta or
F. Or F for Frida.
Or F for Frida, that works. So this is like saying this unknown angle plus 15 has to equal 90. Subtract 15, great. Yep, we're just going to solve it like an algebraic equation. So x would equal what? 75. Yeah,
do we have to write it as an equation or could it just be a...
If you could do it in your head, no, it's fine. You'll see some of them get a... Right, it's just basically 90. Yeah, you could do it like that, guys. I'm just showing you how to make it into an equation because sometimes they're going to get a little more complicated, and it's the same idea.
What is happening with the 90 minus the thing? Why is there minus if you have to add?
Here's what's going on. I think this is a little confusing.
Oh, let's literally
Okay.
the same thing we
Well,
did.
right, this is like the same thing we just did. So let's say if, okay, let's say this is 30, right? Theta is 30 degrees. What's 90 minus 30? 60. Okay, so 30 plus 60 gives you
90.
90. It's just another way to write that they have to add up to be 90 degrees. It'll work for any value you put in. Because if you take 90 minus whatever this is, and you add the two together, it's always going to equal 90 still. But I'm trying to, okay, let's put a first thing in here. Okay, let's say we put in 10. If this is 10, what is this side equal? 80. All right, together, what do those equal?
90, but it looks like why are you like multiplying it with not in my...
That's okay. Are you thinking like distribution?
Yeah.
Okay.
There's only one thing to distribute, and you would only be distributing the cosine to that number.
Right, but these because these are both degree measurements. So technically, they're both degrees. They're like terms, right? So in a parenthesis, wouldn't you do your subtraction first and then multiply, like operations inside a
You're just
parenthesis?
smushing them together.
Yeah. Yep, exactly. They want you to take the value of the degree measurement here and then apply the cosine. Don't think too much into it. The good thing is you guys can check to make sure you're right with these by using a calculator. So what cofunctions say is that these two things are going to be equal. Now, I don't know something about 75 degrees and 15 degrees, so let's use a calculator, and it's saying if I take the sine of 75, it should be equal to the cosine of 15. So try it out in a calculator. Make sure we are in degree mode. It is the same, which is great. So, is it sine 75? Cos 15? Great, they are exactly the same. Okay. And this will work for all of them. All of your, part of what a cofunction is if you know that you have two different trig functions that are cofunctions and their angles add to 90 degrees, they must be equal. So you can always check doing this. I know.
Oh, sorry.
No, it's okay. Should do the whole thing. Yeah, it's not bad. So here, tan and cotan are cofunctions, which means that their angle measurements have to add to be 90 degrees. So if you want to set up a equation for yourself, this is saying x plus 20 plus x has to equal 90. Let's figure out what x has to be. Good. Plus 20 equals 90. 45. Perfect. I don't even know what she's writing.
Yeah, no, you're not.
Actually.
Oh. No, I'm not.
X should be 35.
I'm only 10 off.
You're only
There should be a grace period.
I don't know about that one. Now again, can we check to make sure that we're correct? Yeah. If you guys do the cotan of 35, and we did, let's see, well this is saying 35 plus 20 will give us 55, and I take the tangent of 55, it should equal the cotan of 35. So 55.
This is like simple.
Yeah. How come cotan?
I'm not judging you. I mean, I can.
Guys, cotan, we don't have a button, right? So we have to do 1 over the tangent. So they're the same.
I got the answer for the next one.
Perfect. All right. Why don't you guys try the next one? Okay. Hopefully we got the idea. They're all the same. Okay.
Wait, is this as hard as
This is really easy.
Yes, this is as hard as it. Honestly, guys, I think the hardest part is realizing the connection because there are co-functions. Just that it doesn't come up a lot, so it's hard to like recognize it. Right? And feel free. Go ahead and do this one. See if anybody wants to put it up.
Wait, I think I did that.
Anybody have an issue that I can help? If you guys did it, you want to put it up? It'll be awesome.
I'm sorry.
Yeah, I know.
Yeah, she's here.
Guys, if you got this one, go to the next one. We'll just wing our way through this thing.
Can we just have a thing on the table? Just have it to rattle.
Oh, yeah.
We talked about it. Was it 8? Was it 17? Was it 23?
Written up there, it's just like,
Yeah, wait. I don't have to remember what
all you have to know
I was
from the bottom together. Alright, I think I saw everybody at 17, that looks good. Alright, any takers for 4? I want to put it up. You want to do 5? Alright. You want to do 4? Just straight.
I don't know what I did, but I got 18 twice. Joel, did you get 25 for the last one?
Yeah.
Okay.
Yeah, I know.
Wait, what is that?
Yeah. And then I was just getting up on it because I
Guys, anybody? I know we're all kind of finishing up. One more for 6? Anybody want to put up 6? Adam, you want to do 6? Come on up. We'll get your blood pumping instead.
I don't remember. Well, in space, did she show it? Did she show the photo? Yeah. Oh, like
Yeah, and I have no idea. Because literally it says, after that it says radius, something else, movement, not much time.
That's really where you gotta write it down.
Are you ready for strength today?
Alright guys, so listen, real quick, your homework. You guys should all have a worksheet on your desk for your homework, right? Cofunctions. Worksheet. That's your homework tonight. Okay. Told you guys this is pretty easy today. This is it. There's no crazy tricks going on here.